Example 4.4.4. This example says you are offered the following investment. In exchange for a single payment of $25,770.97 today, you will receive 3 payments of $10,000 at the end of the next 3 years. What rate of return does this investment offer? All right, well, like the other examples, we've got a time value of money problem where we've got a series of cash flows happening at different points in time, and we are asked to evaluate them in one form or another. So we're going to use our 3-step process, where step 1 is to map the cash flows out. Step 2 is to look at that timeline, that map of the cash flows, to identify what type of cash flow we're dealing with. And then step 3, once we know what type of cash flow we're dealing with, we can select the appropriate tool, because knowing the type of cash flow will narrow down what solutions are available to us. So we will start by mapping this guy out. At time period 0, that is today, with this one, we will have a cash outflow of $25,770.97. And then 1 year from today, we will receive a cash inflow of $10,000. 2 years from today, we'll receive another cash inflow of $10,000. And then finally, at the end of year 3, we will receive a third and final cash inflow of $10,000. All right, in this case, we don't know what the interest rate is. In fact, that's what we're solving for. What rate of return does this investment offer? So we can't put the interest rate on the timeline. It's not given to us. All right, so step 2, once we've got all the information laid out on the timeline, is to figure out what type of cash flow we're dealing with so we can then select the appropriate tool to evaluate it. We've got a single cash outflow today, followed by 3 of the same cash inflows at the end of the next 3 years. So we've got level cash flows at regular intervals that stop at some point. I know it's not a perpetuity, because perpetuities would go on forever. So I'm looking at either some mixed stream of lump sum cash flows, or if I can identify it as either an ordinary annuity or an annuity due, then I can use the shortcuts that are available either through the present value, future value of annuity formula, or the time value money keys to solve it all at once. And if we look at our cheat sheet of different types of cash flows under annuities, with the ordinary annuity example, we see in fact pretty much this exact timeline where we have 3 payments of $10,000 at the end of the next 3 years, and there's some present value if we were to discount those back at 8%. And this is pretty much what we're looking at. The other option with level payments is that it could be an annuity due. Well, an annuity due would look something like this, where we've got the same 3 cash flows, but they're all bumped up to the beginning of each year, right? That first cash flow of $10,000 will be happening at the beginning of the year, or today. That second cash flow would happen at the beginning of year 2, which is also the end of year 1. And then the third and final cash flow would happen at the beginning of year 3 or the end of year 2. This isn't what we're looking at here. Our first cash inflow doesn't happen until the end of the first year. So we are indeed looking at an ordinary annuity. All right, so this guy is an ordinary annuity. So our third step then is to select the appropriate tool that we can evaluate, that we can use to evaluate this annuity. And if we're dealing with ordinary annuities, we have 3 options available. We've got the present value or future value of an ordinary annuity formula. We've got the time value money keys in a financial calculator, and as always, the spreadsheet. Spreadsheet we're not going to look at. The solutions are listed in the text, but we'll focus on the first 2 because that's what students will generally have access to on an exam. Okay, let's start with the formula solution. All right, so I have 2 formulas from which to choose. We've got the present value of an ordinary annuity and the future value of an ordinary annuity. And I want to select the formula that will make my life easiest. Either one will typically work. If I'm solving for something other than the present value or the future value of an ordinary annuity, so I'm solving for either the payment, the interest rate, or the number of periods, then I want to select the formula for which I have the information that I can just drop right in instead of having to calculate it. Well, in this example, I have the cash outflow today that represents the present value of this annuity, right? That's what I would spend today in order to purchase the annuity of $10,000. Since I have the present value, I'm going to use the present value of an ordinary annuity formula, where the present value of an ordinary annuity, in this case at time period 0, is equal to the payment at the end of year 1 divided by the interest rate times the quantity 1 minus 1 over 1 plus r raised to the n, right? And this is just equation 4.05 that you can get either from the cheat sheet or on the formula sheet for the text, equation 4.05. All right, let's plug in what we have here, and we're going to find something kind of interesting. We know the present value, that's $25,770.97. That's equal to the payment of $10,000 divided by the interest rate, which we don't know, so I'm just going to use the variable r, times the quantity 1 minus 1 over 1 plus r raised to the n, where n is the number of payments or the number of compounding periods. In this example, that is 3. Now, if I were going to use algebra to try and solve for this, I would have to exploit algebra's tricks to try and get this r by itself. Well, I've got a big problem here. I've got r just by itself here in the denominator under the 10,000, so that's raised to the 1, effectively. We just don't typically write anything raised to the 1 because it's just itself. And then I have the quantity 1 plus r raised to the 3 here. Well, there's not a nice, clean way to be able to isolate r by itself and solve for it with algebra, since it's raised to 2 different exponents here and it's actually inside parentheses and added to something in one of those terms. The best I could do if I were going to try and do this by hand with algebra is I would just take a guess at the interest rate. I would say, oh gosh, I don't know, maybe 10% looks reasonable. So I would plug in 0.1 for r. I would run the equation and see if this right-hand side here, when I plugged in 0.1 for r, actually equaled $25,770.97. And it, of course, it wouldn't. These are the same values we've been using in the previous 3 examples. So we know r is 8%. 10% would be too high. So I would come up with a present value that is actually lower than 25,770. And when it's lower, I know my interest rate guess is too high. So I would adjust it. Maybe I'd try 9%, maybe I'd try 8%, 7%, whatever I adjust it to, try it again. And then I would just keep going through that iterative process until I got it close enough and I was satisfied. Of course, that's going to be pretty labor intensive. There's lots of opportunities for mistakes, and it's going to take a while. It is much better when we're solving for the interest rate on something like an annuity to just go ahead and reach for the time value keys on the calculator. Right? We actually have 2 ways to solve this one with the calculator. Let's start with the time value money keys. Okay, where those are the N, I over Y, PV, PMT, and FV. All right, and again, this is just the system that I've gotten used to using. There's no magic to it. I just do it the same way every single time, where I write the keys in my notes in the same order that they appear in the calculator from left to right. And then I go ahead and put everything in my notes so I can track what I put on the calculator. Of course, you don't have to use this system, but I do encourage you to come up with a system that you use the same way every single time, because it'll help reduce the errors that you encounter that are much easier to encounter if you're just randomly entering things on keys in all different orders for every problem. All right, N, and this one is the number of payments. That's 3. I over Y is what we're looking for. We've got the present value for this one, and here we're going to be entering information on all 3 cash flow keys, on the PV, the PMT, and FV. So keeping track of the relative direction of the cash flows is going to be really important for the calculator. And we'll see, after we calculate it, we'll see what happens if we don't get that right. So present value, I'm going to adopt the perspective of my pocket, which means I'm going to have a cash outflow. Because I'm the investor, I'm going to pay $25,770.97. And that means I will have 3 cash inflows of $10,000. So I'm going to record the payment as a positive. Remember, the payment key is tied to the N key. Whatever value we put on the payment key, the calculator is going to assume that we're getting the number of them that we put on the N key. So in this case, we've told the calculator that we're going to receive 3 cash inflows of $10,000. The future value key, I'm actually going to put a 0 there. That's not because the future value of this annuity is 0. We know it's not because we've worked with these same cash flows in the previous values, in the previous examples. But what we're putting on these cash flow keys is what actually happens on the timeline, right? And not necessarily the present value or future value of this particular annuity. So we have a cash outflow at time period 0 of the $25,770, and we have 3 cash inflows of $10,000. We do not have any additional cash flows, additional as in addition to the last payment of $10,000, which we have already recorded when we say N equals 3 and payment equals $10,000. And so we don't want to put anything on the future value key here. If we were to put something on the future value key, it would be telling the calculator that we receive it in addition to that last payment, and that's not what's happening in this particular problem. Okay, let's get these guys plugged in. We're going to start by clearing out the time value money keys, recording zeros in all of them by hitting second and clear TVM. And then I'm going to work left to right. N is 3, so I press 3, and then N. I over Y is what I'm solving for, so I'm going to skip over it. Present value is 25,770, 97. I'm going to press the plus minus key to make it negative, because from my perspective, it's a cash outflow. And then press the present value key to store it. Payment is a cash inflow of 10,000, so I'm going to type in a positive 10,000. Press the payment key to store it. And then future value is 0, which when we cleared it out, it should have recorded a 0, but just to be sure, I'm going to go ahead and press 0 and then press the future value key, so I know for sure that that's what's on there. All right, we have 4 of the 5 variables in, so the calculator can solve for the 5th. We'll hit compute I over Y to get the interest rate, and we get, of course, what we were expecting because we've been working with these cash flows for a while. We get 8, or 8%. It is giving it back to us in percentage format. Okay, so what does that number mean? That number means that if we were to pay $25,770.97 and then receive 3 cash inflows of $10,000 at the end of the next 3 years, then we would earn an 8% rate of return on that investment. Okay, now before we go to the second way we could solve this with the time value money keys, let's talk about what happens if we do not get the relative direction of these cash flows correct while we're putting it in the calculator. Let's say I just got in a hurry and forgot, and I record both the present value and the payment as positive values. So I tell the calculator that there's a cash inflow of $25,770.97 at time period 0, and then that is followed by 3 cash inflows of 10,000, and then I ask it what is the rate of return on this investment. We're going to get an interesting answer. I'm going to get error 5 from the calculator. Now, you could get error 5 solving for many of these variables. You most commonly encounter it when you're solving for I over Y, or your interest rate, or N, the number of periods. And that's because in order to solve for one of those variables, you would have had to enter something on the present value key, the payment key, and the future value key. And so if you get the signs wrong on those, then you're going to get that error 5. Error 5, we'll get used to seeing that. It is an indicator of a sign error. Anytime you see it, when you go and you say compute I over Y, error 5, immediately you should think, oh, okay, I've got a sign error. I've got to go back and check the relative direction of these cash flows. All right, so in order to get those signs right, what's positive and what's negative, what you want to do is adopt a perspective to track the cash flows from, and then be consistent throughout the problem. The way I've entered it, we're using my pocket as the investor as the reference point. So the $25,000 is a cash outflow up front because I pay it, and then the $10,000 is a cash inflow because I'm going to receive it. We could just as easily adopt the perspective of the one who is selling this investment, and in that case, this person would have a cash inflow of $25,770.97, but then this person would have to pay, would have a cash outflow of $10,000 over the next 3 years. So if I just flip the signs on those, I make the present value positive, the payment negative, and I say compute I over Y, I'm going to get the same correct 8% back. And that's because I'm looking at the exact same cash flow set. I've just changed my perspective from the investor to the person who is offering the investment or selling the investment. And either way is correct. You just want to pick one of those perspectives and use it throughout the problem. Okay, I said there's one other way we could solve this with the calculator, and that is with the cash flow worksheet. And with the cash flow worksheet, the way we get into it is by pressing the CF key. And this guy is a memory function, just like the time value money keys. So we want to start out by clearing it and zeroing everything out. And the way we clear out the cash flow worksheet is by hitting second and clear work. Second and clear work on the bottom left. And then once we're in here, what we want to do is enter the cash flows exactly as they appear on our timeline. Cash flow 0 is what happens at time period 0. For us, that's a cash outflow of $25,770.97. So we're going to record a negative $25,770.97 on CF0. And the way we do that is by, while CF0 is on the screen, we're going to type in 25,770.97 plus minus to make it negative. And then we have to press the Enter key to store it, right? So once that's in there, we press the Enter key to store it. And then once that's stored, we hit the down arrow key to go to the next entry. So down arrow key. When we hit the down arrow key, the calculator shows us CO1, which stands for cash flow 1. And what it's asking for is after that initial time period 0 cash flow, what happens at the end of your first period? And for this one, that's a cash inflow of $10,000. So we're going to record a positive 10,000. 10,000. We're going to press Enter to store it. Okay, so once we've typed in the 10,000, we'll press Enter to store it. And then we'll hit the down arrow key to go to the next entry. When we hit the down arrow key, this time it comes up with FO1. And FO1 is the frequency of cash flow 1. That is, this $10,000 that you just entered for cash flow 1, how many times in a row do you experience that cash flow? And for this problem, we get it 3 times in a row, the end of the first year, second year, and third year. And so we are going to enter 3 for FO1 to tell the calculator that we get it 3 times in a row. So we'll press 3 and then press Enter to store it. All right, and at this point, we have entered all the cash flows associated with this particular problem. Now, I mentioned this is a memory function, and I'm a little paranoid, so what I like to do after I've entered all the cash flows is hit the down arrow key a few times just to make sure there's nothing else in there. When I hit it once, I see CO2 is 0. Notice there's no triangle or equal sign, so that means nothing is stored on that value, which is good. That's what I'm hoping for. If I hit the down arrow key a second time, FO2 is now 0. By default, it's 1. So when I see 0 here, no triangle and no equal sign, then I know that nothing is stored there, and that's a good sign. And if I hit the down arrow key one more time, if nothing else is stored in here, it should take me to the top of the list. It should take me back to CF0, and it does. So we're good to go here. All right, now we want to find the interest rate that equates this cash flow 0 with the cash inflows that we receive over the next 3 years. And the way we do that within the cash flow worksheet is by pressing the IRR key. IRR stands for internal rate of return. We'll look at in later problems, but it is just the rate that will equate this initial cash outflow with the 3 cash inflows. So we press the IRR key, and we get a compute prompt in the top left, because it says it has enough information to calculate this. Do you want me to actually calculate it? And of course we do. That is why we put this information in here. So we'll then hit the compute key, or CPT, and it will go through that same iterative process that we would have had to do by hand, but of course it can do it a lot faster, and it will tell us that IRR is equal to 8, or of course it's giving it to us in percentage terms, so that is 8%, which is the same thing we got with the time value money keys, and it's in fact going through the same process to calculate it. So there we go. We've got two ways to actually use the finance functions within the financial calculator to solve this particular problem. Of course, you don't have to do both. Select whichever one you are most comfortable with or whichever one is most appealing, and then you're good to go. I'm just trying to show all the options in these videos.